No.
Howdy ho! It's Nicole.
Nope.
Ooh.
Atomic Theory, Unit 1.
Yep. Vocab.
Vocabulary
Let's
Notes
learn us-
Lecture 2.
Yeah, let's learn us some 20 words.
Learn us some words. Let's do it.
All right.
I go first?
Oh, as always.
Oh, you know what? Then I'm not going first.
Oh, feeling some kind of way? Come on.
All right,
to do
fine.
it.
Anion, if you insist.
Oh, first.
All learning targets is standard. I can define the specialized vocabulary of the atomic theory unit.
You
Simple
can do
enough.
both.
Anion, great picture. It shows an electron joining an atom, becoming an anion through the addition of an electron. But the definition is an ion that has a negative charge because it has gained an electron. It's tough to remember because electrons have negative charges. But when you pick up an electron from somewhere else, you gain a negative charge. And
Correct.
we call that an anion,
Yes.
a negative ion.
Yeah, I remember my kids very vividly at the beginning of the year thinking adding -1 was no big deal. But when
It
for
really
some
is.
reason it's going to become a big deal.
Mm-hmm.
And here it is, because we're adding and it becomes more negative.
Algebra.
Atom. So, nice fancy picture. This is the smallest unit of an element that maintains the properties of that element. And as we learned last unit, let me add on, ready? Cannot be broken down by chemical means, correct?
All right, atomic mass. This has to do with how many protons and neutrons are in the nucleus of an atom.
So, right there, the mass. Protons plus the neutrons. That's what the picture was showing you.
Atomic number. This is the number of the protons in the nucleus of the atom. And it's the same for all of the atoms of an element. So all gold atoms have the same atomic number because they have the same number of protons. It's the basic definition of what makes one element different than another. It's the number of protons, aka atomic number.
Yeah, protons are king. We will find that out. This is called a cation. It's not a cation. It's a cation. Similar picture to the anion, except for here we see the electron is leaving us with just a plus. So that is an anion that is positive charge because it lost an electron. It lost a negative, and all that's left is the positives.
We've got ionic charge. That is the number of protons minus the number of electrons. Right?
Yeah.
It's the charge that's left over.
Yeah, and it's specific to that particular order because it's subtraction. So it's always got to be protons minus electrons to get the right charge.
Yeah.
Yeah, buddy. Got it. Just make sure to make
Electron. One of my favorite subatomic particles. I have 3 favorite subatomic particles.
I knew you would.
Maybe you'll get the joke later on. But it's a subatomic particle with a negative charge, has no
I
mass,
just got the
and
joke.
resides in orbitals. Remember, I have 3 favorite subatomic particles. Electron is one of my 3 favorites.
Nice.
There you go.
Electron configuration. We will use the periodic table to get numbers like this here, the 2882. And this tells us the arrangement of electrons in the atom.
Mm-hmm.
Heads up, those were not subtraction signs.
No.
Those were just space holders.
Uh-huh.
And we will learn how to read what that electron configuration is. It's going to tell me not just how many electrons, but where.
This their address.
Yeah, there you go. It's very much like an address.
Next up, we've got elements. It's a unique kind of matter, can't be broken down by chemical means. Should sound familiar from last unit.
Yeah, and it's generally referred to as never just a single atom.
Right.
An element kind of refers to a collection of the same kind of atom.
It's just, yeah. Mm-hmm. Excited state. After lunch, the electrons are in excited states. Well, an electron can move. Okay, they can move between its discrete energy levels, and when it goes from its home address up to a higher energy level, we call that higher energy level the excited state. And that electron's gonna come back down as soon as it can.
To, of course, the ground state. So this picture is trying to show you that it goes from the ground state up to the excited state, and it's going to come back down to the ground state, and we'll learn what happens when it does that. But this ground state is its normal or lowest energy state. This is where it would normally reside.
Yeah, home address.
There you go.
Next up is an ion. That's when an element has more or less electrons than it normally would have. An anion or a cation are types of ions.
Basically have a charge.
Yeah, positive or
an overall.
negative. Mm-hmm.
That's good.
Isotope. This is another one of those I words.
Yeah.
Isotopes, mad important, man. 3 isotopes of hydrogen. There you see, these ones got different names: protium, deuterium, and tritium. But what's really important is that the same number of protons, different number of neutrons. And therefore, since it's got different neutrons, the mass is different. Therefore, you got heavy or light elements. And they behave slightly different than the average element, so to speak.
Mhm.
So isotope, that's a definition.
Yep. That is a game of neutrons.
Fat or skinny elements.
Ions is a game of electrons. This is a Bohr model, what we call the planetary model.
Looks pretty boring.
Yeah, I guess that was Family Guy. Diagram of showing not just the nucleus, but all the energy levels and the electrons in each energy level.
Yeah.
So this is like the map with the most info.
It's a map of the atom.
It really is.
All right, next up is neutron. That's one of Monaco's favorite.
One of my 3.
Yeah, one of the favorite subatomic particles. Has no charge and it's found in the nucleus.
Very good.
It does have some mass.
Oh yeah. What is a picture of?
Nuclear charge.
Nuclear charge. Ooh, I love effective nuclear charge. Nuclear charge is really simple. It's the charge of the nucleus. And the protons and the neutrons are in the nucleus, and the neutrons is neutral, so it's the charge of the protons that the atom has. So if it's got 10 protons, the nuclear charge is plus sign 10. If it's got 12 protons, the nuclear charge is plus sign 12. So atomic number, protons, and nuclear charge are technically all the same thing, even though they're talking about only one of my favorite subatomic particles.
Yeah, and somehow it still can be confusing. Probably because I need 3 names for the same thing, which maybe is doing too much, but it is. All right, here is a picture of the 3-dimensional shapes of orbitals that we do not need to learn.
But they're pretty.
They are. This is the region of the highest probability of finding an electron.
Yeah.
Now, I did that because the calculus comes out that is the actual written word definition. We not do it a calculus. You know what an orbital is, and we move on. Let's keep it simple.
All right, next up is the proton, another favorite subatomic particle. Has a positive charge. It's in the nucleus, and it determines the atomic number.
Yep.
Very good.
Boom. Valence electrons. Well, electrons are another one of my subatomic particles that are favorite. The valence ones are on the outside of the atom. These are the furthest away from the nucleus. These determine the chemical properties and reactivity of all elements. They're very, very important. Actually, they're the most important electrons as far as I'm concerned.
Absolutely. Because you think about that, 2 electrons ever come in contact with each other, 2 atoms ever come in contact with each other. Their outermost rings is all that's ever going to touch. So this is where all the games are going to play with electrons. It's going to set us up for unit 4 bonding, 3 bonding.
Yep.
Yeah, buddy. Lewis dot. This is the second kind of picture. This is an easier picture than Bohr, because Bohr had all those rings. This is a diagram showing my element symbol and just my valence electrons, because those are, like Monaco just said, the most important of the electrons.
What else we got?
Dude, is that 20 maybe? Let's
Close.
check. Oh my gosh, it is. You messed up last time. You went for a little bit, so we're not messing up at this time.
Not this time. Anything else to add, vocab?
Sounds good to me.
Yeah, how about study your words, pass your vocab quiz in less tries than last unit? How about we do that?
I would love that.
I would too. And with that,
Yep. That's all, folks. Please don't sue me, Warner Brothers, for